Good. So while the M table was basically a project where we gave the technology at the fingertip of a potential co-author, a user, end user of the table, it was still not architecture. So for us, the question was, well, in these experiments which we did in the early days of our practice, and in parallel we also did buildings actually, but we show here the experimental part, was, well, how can we bring these resolutions, these new ways of designing maybe to physicality, and how would that physicality change? And I mean, already the table, if you maybe not only look at it, but start to touch it, actually, one of the table is actually mine, the wooden one, so I eat there with my family every evening, etc. And when you sit there, you know, you start to put your hand on it, and your hand goes down in one hole, and you start to, you know, touch the rim, etc. So the kind of the physicality of what the digital can produce was, I think, an ongoing quest, and still is. And this project, Interference Cube, touches on that, and there was also, I think, one of the source inspiration to later talk of digital materiality, to basically say this quest for how the digital can become material. Maybe there is something which we could call that, namely a coming together of the digital and the material in something new. And that's what we call the digital materiality. So from the outside, it's just a cube. It's, I think, 7 ton. We had to kind of look back into our archives to figure out again. I think it's 7 ton heavy, this thing. It's made out of 5 similar concrete plates, but what it was really about is the way on how we designed the inner surfaces. So this is the code that's producing these inner surfaces, these qualities as we see them. And it uses a mechanism which at that time was available in some software package called Maya, where you can actually work with force fields. And we started to work with force fields in many other projects. We're going to see some of them later, because we were interested in the fact that you can not only in a computer design by, in a CAD, drawing a line 2-dimensionally, or building up a 3-dimensional surface, so modeling, but you can also conceive of space as forces. You can conceive of distances and the relation between points in a virtual space, and these relations can be designed. You can say, what could this virtual space mean? What are these relations? And how can you make something physical out of it? So in this case, we were using these forces to kind of create a complex pattern. And here you see the representation of the spatial pattern, depending on how you look at it. And if you squeeze your eyes a little bit, you see interferences in this pattern. You see some formations which form. This is basically the character, one representation of the character of this spatial field. Or if I say it in other terms, if I talk to you, the room is full of information, right? The space is filled with densities of waves going out. This is something similar in a virtual space. And we said, what if we take this as an ingredient and we use this to ornament, to imprint, basically, physical material? And actually, this principle, and it's still not widely used, we could still, if we would have big commissions, actually really continue working on this, and it would also be interesting. It's a principle where we now take a geometry, in this case a simple cube, to show it in its most abstract and radical form, but we could actually take any geometry, put it into that virtual field, and then start to imprint this geometry in a way that it's transformed, but it's also consistently transformed. That means, I think we can see this here to some degrees, That means imagine now there's sound waves here in the room, and now you cut these planes of a cube into these waves. So now, if you are in an edge, the information is the same at the edge for both of the plates. And that you can, for example, see here. You see that every of these ripples, even though it looks like a break, actually continue. You see it really well here because it's almost symmetrical here, the forces. So it's really a space which is then transformed into these planes. It's a principle which we could apply on any geometry, and it's a provocation to how basically ornamentation or a further development on how ornamentation today is done, because ornamentation often today is done in a very visual sense. You say, okay, this is a surface. You create continuity by basically drawing on it, be it with a relief or with an image. And here there is no image. It's abstracted, and it's then becoming an imprint. So what we did is this. We had each of these surfaces was milled from a MDF panel. This panel was then put in a formwork. This formwork always stayed the same, but this panel was changed. You see it here. And that's kind of a magic moment for us, because that's where the fine, high-resolution digital comes together with the very crude concrete. And that's where kind of then this digital materiality starts to be created, in a sense, in this process. And I think that was an important moment for us, because, I mean, we were ourselves not so sure what this only, I think it's 8 millimeters of difference actually do to the concrete. But what we sensed is that when you put this together, everyone that saw it at the moment somehow was looking at it and wanted to understand what this is. So it's a simple ornament, it's nothing so special, but almost everyone also wanted to touch it. Right? And so that kind of gave a bit of curiosity to us to say, well, maybe this digital really brings something else to the physical. We might see different things in the future because the digital expresses itself. And I would say, while this is only, let's say, one of the beginning or the curiosities which was created with us later on, we also then saw it's not only bringing the digital to the physical, but also about let's say the dialogue between the digital and the physical, which starts to elaborate like in installations like we see here. Good. So the cube you see outside here, again, this continuity which you can feel, and you can imagine now if you put the complex geometry in this spatial field, that if you would, for example, have continuous curves, then you would have continuous patterns. If you start to have edges, you get ruptures because you have different reading of this virtual field, etc. So there is an interplay between the geometry and this virtual ornamentation. Good. Then we did this photographic work, which is exhibited here, the closed state and the open state. These are all, a number of former friends, and some of them still friends, which we kindly asked if they would go naked in the cube, because we wanted to kind of then express this relation between this raw materiality and the human. So what would this encounter be? And the photographer Roman Keller, who is himself an artist here in Zurich, made this piece. And we did it because we only had one cube. In fact, we did it like this. So basically, Roman took different perspectives to this one cube, while the nudes were enjoying themselves in the concrete. It was quite cold, actually. We kind of went on speculating a bit. This video is also in the exhibition. I think that's a bit a slower version, saying, well, what could that become if maybe an aggregation of these cubes would actually follow the same principle of formation as the content of the surface of the cubes. So that's a bit manieristic, but I think it shows our fascination at the time with these spatial patterns. And of course, this would not stand up. So today we would say it's impossible if our students come with this, but at that time we were really enjoying that freedom. Good. Maybe before we go to the next project, a quick intro here. This installation was made for the Swiss Arts Awards in 2003, it was. And then we didn't win it. And so we were very frustrated because we really liked the piece. We thought it was quite an achievement. And the jury, we got actually feedback why we didn't win. What they thought is, well, that was a lot of effort, a lot of basically money put into making this installation, and they consider art to be basically to be elegant if you invest less, right, for achieving a certain result. So they thought it is kind of overdone. For us as architect, we didn't look at it that way at all, because what we did with information was actually, let's say, minimal and relatively subtle, I would say. And the transfer to reality for us was finding an industry partner who was crazy enough to say, okay, I'll do it. So, or actually two industry partners, one that did the CNC milling and the building. So for an architect, this was basically normal. It also didn't cost us anything. But the jury thought, you know, this is too much. So then the next year we thought, okay, we're going to enter again. And then we presented the Byte Cube. The Byte Cube had the same format of, what was it, 2.3 meters, I believe, as a cube. And we did a very simple thing. We took all possibilities in a byte, so between 8 times 0 to 8 times 1, so from 0 to 255, all combinations. And we said, well, it's interesting because a byte has 8 bits, but a cube also has 8 edges. So we just run this code. We basically count from 0 to 255 in a cube. And whenever this state comes to a spatially meaningful plane, we do a little wait. So here, the installation pauses. So these are high-power LEDs which we were using, and then it continues to count. So we said, let's be minimalistic, but take the reference to last year's work, and we won the Swiss Art Award. So that's the story of this. So persistence pays.